Hello, class. Almost the weekend again, and in the middle of tax season. I hope your taxes are done. Well, I'm going to talk to you today about a new antibiotic. So I'll talk a little about terminology. An antibiotic is a broader category called also antibacterials. So an antibiotic is an antibacterial that also inhibits the growth of the bacterium in some way. So there's other, like for instance, sulfonamide drugs. They're antibacterials. They're not antibiotics. And because sulfonamide works by preventing the formation of folic acid, and so then that just causes the bacterium to die. Whereas for us humans, we get our folic acid from our diets, so we're okay with that. Then penicillin, for instance, it interferes the way that the protein coats surrounding the bacterium, specifically the cross-linking of the protein, and so it prevents that specific part in the growth of it, and so it's an antibiotic. So all antibiotics are antibacterials, but not all antibacterials are antibiotics. And so this is an antibiotic, so it interferes with the growth of the bacterium. And what's interesting about it is, so it's non-toxic to humans, and it interferes with a specific step, and it deals with the protein synthesis. And why do we care? Because bacteria are becoming more and more drug resistant. So we need to be ahead of the game and have more drugs that the bacteria have not evolved around. And why is that important? Because that is how people used to die. So people on my age, I am in my 40s, and below, people my age and below, the typical cause of death is accidents. And unfortunately, also increasingly, I know, so overdoses on drugs, that's still considered an accident. So, older people, what primarily kills them are cardiovascular, and cancer. So heart disease, stroke, and cancer. So that's generally what kills older people. Younger people generally get killed by accidents. That was not always the case. What usually killed people was disease, like pathogenic disease. And so one of our major safeguards in that are antibiotics. And so, antibiotics, and what's nice about them is they tend to be, they can be very broad spectrum. So antivirals, when we're looking at viruses, antivirals tend to be very, very specific for certain viruses or classes of viruses, whereas antibacterials can be fairly broad spectrum. So, and again, this is how science is improving our life. So we put a lot of energy into researching these and new drugs. And I know maybe people don't like big pharma, but this right here is the perfect thing for big pharma, because this is a product that can be marketed and sold, and a lot of people are going to buy it. So it's a single product that's going to have a large market. So this is a good thing. And so this is like the bread and butter for a lot of pharmacy companies. Like, oh, we found a drug, and now we patent it, and we can make money off of this drug. What's unique about this drug? So the Lasso peptide called Lauricidin. So, and what this molecule does, and this is a peptide, and this just shows the different amino acids. So proteins, the primary structure of the amino acid, this is the amino acid. It's a pretty small molecule. It's not very big, right? And so that's the primary structure there, and it shows a little bit of the secondary structure, although it's not very big as far as a protein. Secondary structure is usually the alpha helices or beta sheets that are in there, but it is kind of showing a little bit of the 3D arrangement in space. This would still be considered a peptide because there's just so many few amino acids. Protein's going to have huge amounts of amino acids. And how does this stuff work? well, let's see here. Where is it? It's and it affects the ribosomes, so ribosomal RNA. Kind of a brief show of how hereditary material work in cells. So the DNA or RNA, I guess it's more RNA for viruses, but for the rest of the cells, DNA, the DNA can unzip. Messenger or mRNA forms over the DNA, and then the mRNA goes to the ribosomes, and then the different amino acid the nitrogen-based sequence will tell the ribosomes what amino acids to put together, and then the transfer RNA will grab the different amino acids, and then the ribosomes will then go and assemble the protein. And for animals, for many things, plants can get their structure from cellulose, but everywhere else, so us mammals and we get our structure from proteins, including bacteria. And only that are enzymes, the ones that do chemical reactions and that kind of thing. It's all about the proteins, about the protein shape, and that's how the protein functions. And so what this drug does is it mucks up the acceptor site where the amino acid, where the tRNA binds. And because of that, it does not read the mRNA correctly, and then the proteins don't get made in the proper manner. And if the proteins get made in the proper manner, they're not going to have the right shape. The enzymes are not going to have the right shape. The structure of the cells or whatever they're building is not going to have the right shape. And then because of that, it's not going to function. So this is how it interferes with the bacterium, and this is how it ultimately causes its death. So, or it messes up enough that the patient's immune system can overcome it. And what's cool about this is they found this in someone's backyard. It was, this was discovered in someone's backyard. So that's kind of cool, that what treasures you might find. So, and just looking around, the article doesn't go too deep into it. Maybe they saw that, there's less bacteria here. I wonder why. Oh, look at this interesting molecule. Oh, wait a second. It seems to be fine for us. So this is not at the level of where they're doing clinical tests on humans yet. They haven't really even tested it too much on humans. Look at some human cells. But it's not like, we're having, people with earaches and strep throats take the stuff to see if it cures the disease. So we're not there yet, but we're getting there. But I think this is cool. It shows you, that we are looking for new drugs, and it's still amazing, that look at that, how quickly we can find that. And this one, this is a discovery, literally in someone's backyard. Yeah, so here we go. Cultivated from a soil sample and tame here in Hamilton from my technician's backyard. So, we're still finding drugs this way. I've given other talks about like how AI, for instance, is looking for things, and we're also looking really closely at protein structure. So like the protease inhibitors that we have for viruses that I've mentioned before, how those work. So we do have that we're really, using our chemistry knowledge and or artificial intelligence, looking for ways we can interfere specifically with a virus's life cycle, for instance. And then we're also, in a certain place, like, oh, I dug this up in my backyard. Let's take a look at this. Oh, I found something interesting. Let's make a drug out of it. So that's kind of cool, that we're still doing that. And I mentioned before sulfonamides. That was the original antibacterials. So that was the original one. Also the original antibiotic was penicillin. So I remember that, sulfa predates penicillin. And my grandmother worked on penicillin. That was she was a chemist. So that was interesting to learn that about her. Although it was not discovered by my grandmother. I forget who discovered it, but I know that noticed that bacteria didn't grow around certain molds and petri dishes. So That again, another sort of accidental kind of, oh, look at this stuff, that's kind of cool, let's figure out what's going on, discovery. So, well, I hope you enjoy this and maybe a little comforted by the fact that we are finding new antibacterials or antibiotics. I guess in this case it is a proper antibiotic, and hopefully stay ahead of the curve so that we all live to a nice ripe old age and not have to worry as much about pathogenic diseases. So, and with all my correspondence, I hope you are doing very well. If you're not doing very well, if you're not getting your basic needs, if not being met, if you are dealing with crippling mental health issues, if you have academic problems or whatever, anything else, let me know. And if you reach out, I always do what I can to help you. Reach out into my network. So we'll have a nice rest of your day and weekend. And if you haven't yet, get your taxes in. Aloha.